Hey everyone, wanted to show you a project I've been working on. What you see here is a pedestal that I bought used from an integrator who builds special machines. I've got a special project coming up here that's quite important, and we didn't have time to have someone build a new pedestal for a piece of equipment we have. So I thought, hey, let's find one from one of our integrators and I can modify it as needed. So here you see this pedestal unit, and it is used for holding a piece of automated equipment that a robot will feed parts into. Here you see the mounting bracket on the top of the pedestal. Here's a view from the back. Here's a view from the front. There's a flat plate that you can partially see there. It's on the left side at the top of this screen, and it is used to hold the automation. So what you see there is the CAD work I did to get the design in so I could develop the proper height. The height of this pedestal when I picked it up was 73.5 inches. I needed to make it 26 inches. I was using my little Harbor Freight cutoff wheel, and I made about this first cut here and realized this was not going to get it done. So I ended up using my sort of some finger grinder instead of the cutoff wheel, and it went pretty quickly. Since I'm working by myself here and trying to do this safely, I cut all four sides of this, leaving the four corners intact. Then what I did afterwards was I added my shop crane into the equation and strapped it to the top of the pedestal, and I then cut the corners while I had a light amount of up pressure holding the pedestal so it wouldn't fall. Ended up working out really good, and we got the thing cut. I'm only showing you this one cut in the video, but I obviously had to do all four sides and then cut a large section out of the center of this 4x10 steel tube so I could then weld the top and bottom section together. Now here you can see that the four sides are cut minus the four corners, and I have my shop crane hooked up so I'll be able to safely cut it off. I'd like to interject something important here. For God so loved the world that he gave his only begotten Son, that whosoever believes in him will not perish, but have everlasting life. For God did not send his Son into the world to condemn the world, but that the world through him might be saved.
Don't be a dum-dum. Put your safety glasses on.
Okay, Arco, they are on. And here I am cutting off that bottom section. Now I'm showing you the CAD work, so I knew exactly how much to cut off, so the tool on the end of the mounting plate would end up at the proper height. Here you see how I aligned the top section with the bottom section. I basically used some flat plate to align the side surfaces and C-clamps to hold in place while tacking. Hey everybody, how you doing tonight? It's Mother's Day. Happy Mother's Day to all the ladies watching and to all your wives if the guys are watching. I've been working on this project the last couple of days. Sorry for the light, although I just banged it and the light got dimmer. Maybe that'll be better. This is a pedestal, and we use them a lot in different automation applications where there's robots feeding parts to some sort of a machine. In this case, it's a machine that clinches two pieces of sheet metal, two sheet metal stampings together. A clinch is a mechanical joint that does not require a screw, a rivet, a nut, any kind of fastener whatsoever. It's just the parent material that is joined. Well, when I picked this up on, I guess it was Friday, this was 6 feet tall, okay? The application, which this is kind of an emergency quick job, is going to be holding with a large bracket up here a unit that looks similar to a spot welder, but it's called a clinch gun, okay? Ford Motor Company has embraced this a lot in their manufacturing process. The aluminum F-150 uses a series of clinches like we're doing here, and something called self-pierce rivets, which is another mechanical joint, but it requires a fastener. So it's a little more complex and more costly. So they'll clinch anytime they can. So anyways, I cut 20 inches out of this pedestal yesterday. Today was Mother's Day. Spent the day with my wife and my mom and my daughter, who's also a mom. And so I got out here tonight and set this top on the bottom base. And now I'm going to be welding all around. So, hey, enjoy. Take care. I know I'm not wearing any gloves, but I don't like to. Okay. Put that aside for a second. Let's chips over that slag off and see what we got. This is my root pass. It's hard to see on the video, but I've also beveled these edges. This is 3/16 thick, 4x10 steel tubing. Not too shabby. I'll go around and clean this up good after I get done with this first pass. I think I'll switch over to this side. I still need to put the headlight on my welding helmet so I don't have to move that other light around all the time. After laying down this root pass all the way around, I put the pedestal on its side, and then I did the final weld all around, and I spared you the agony of watching me do the grinding and cleanup. So the tube looked like it was one solid piece instead of welded through the center section. All right, that's good. Welding on a horizontal weld on a vertical surface. Got to watch out for gravity. It's something to keep in mind. I run the rod a little bit high, just a little bit. Yes, these hollow tubes are loud. This top and bottom plate are both 1-inch steel plate. These gussets are these are 1/2 inch, and this one is 3/4 thick. Yeah, I'm gonna go around this side. Stick's getting a little short. Well, this is a short area. Good. Here you see the pedestal with a coat of paint on it. I did one more coat after this one. Here you see me doing the machining. I had to put a new hole pattern into the old mounting bracket because it obviously was different than the spot welder that had been mounted to it previously. You can see a little bit of the setup here in some of these pictures, and ended up working out just fine. Everything mounted up great. I had to machine a fitting for the 480 bolts to come into the panel, and then here's the final paint. And here is the mounting bracket, also after the final paint. And then finally here you see the machine mounted on the pedestal in our lab, ready for doing the clinching that we need to do for our customer. And finally, I wanted to show you what a clinch joint looks like. Here are a couple of pictures. You see we create an interlock between the upper and lower sheet, which creates a permanent mechanical joint.